The science of space dust and its effects on spacecraft is a critical area of study within the field of space exploration. Space dust, also known as cosmic dust or micrometeoroids, consists of tiny particles from comets, asteroids, and other celestial bodies. While these particles are minute, often no bigger than a grain of sand, they can pose significant risks to spacecraft due to their high velocities and the harsh environment of space. Space dust is ubiquitous in our solar system and beyond, and its interaction with spacecraft has both scientific and engineering implications. From a scientific perspective, space dust can provide valuable information about the composition and dynamics of celestial bodies. Studying these particles helps scientists understand the formation and evolution of our solar system. For instance, analyzing the composition of dust collected from comets can reveal insights into the early solar system's conditions and the building blocks of planets. From an engineering standpoint, the high-speed impact of space dust poses a threat to the integrity and functionality of spacecraft. When a particle of space dust collides with a spacecraft, it can cause physical damage, such as pitting or cratering on the surface, and in more severe cases, it can penetrate or disrupt spacecraft systems. This impact can compromise sensitive instruments, solar panels, and other critical components. The velocities of space dust particles, often exceeding tens of kilometers per second, significantly enhance the energy of their impact. At these speeds, even tiny particles have enough kinetic energy to cause substantial damage. This phenomenon is a primary concern for spacecraft traveling through regions with high dust concentrations, such as near comets or in the asteroid belt. One of the notable instances of space dust impact was observed on the Hubble Space Telescope. Its solar panels and other external components showed signs of micrometeoroid impacts, underscoring the prevalence of space dust in even near-Earth space. The International Space Station, ISS, also faces risks from space dust, and its modules are equipped with shielding to protect against these particles. To mitigate the risks posed by space dust, spacecraft are designed with various protective measures. These include using materials like Kevlar and Whipple shields, layers of protective material spaced apart to disperse the energy of an impacting particle. Engineers also consider the orientation of spacecraft to minimize the area exposed to the direction of travel, reducing the likelihood of direct impacts. Understanding the distribution, size, and velocity of space dust is crucial for mission planning and spacecraft design. Space agencies conduct extensive studies to map out the density of dust in different regions of space and adjust mission trajectories accordingly. This knowledge is vital for ensuring the safety and success of missions, especially those venturing into less explored regions of our solar system or to other planetary bodies. In addition to physical damage, space dust can affect spacecraft in other ways. For instance, dust accumulation on solar panels can reduce their efficiency, impacting the power available for the spacecraft's systems. Dust particles can also interfere with optical instruments, obscuring observations and affecting scientific data collection. The study of space dust has also led to advancements in materials science and engineering. Researchers continuously develop and test new materials and shielding techniques to enhance spacecraft resilience against dust impacts. This research not only benefits space exploration but can also lead to advancements in other fields, such as aviation and materials engineering. Moreover, space dust presents an interesting challenge for future manned missions, particularly to Mars or the Moon. Protecting astronauts and habitats from dust impacts and ensuring the longevity of equipment exposed to these particles are significant engineering challenges. Solutions for these challenges are essential for the long-term sustainability of manned space exploration. In conclusion, the science of space dust and its effects on spacecraft is a multifaceted field that combines astrophysics, materials science, and engineering. Understanding and mitigating the impacts of space dust are critical for the safety and success of both current and future space missions. As we continue to explore the cosmos, addressing the challenges posed by space dust will remain a priority, ensuring that our journey into the depths of space is as safe and fruitful as possible.